right, this is the Virginia Geometry SOL 2013 solution, starting with number 11. All right, let me get my little box out of the way. All right, line T contains these 2 points, -8, 5 and 8, -3. Identify the points other than point P with integral coordinates that is on a parallel line parallel to T and passes through point P. Okay, so you don't need to stress about all those words that you're not familiar with. Think of it as this line contains these 2 points, and we want to plot another point that is parallel to the line T that passes through point P. So first of all, let's find our slope, M. So 8, -3. Then we have 8, 5. So I'm going to draw my handy-dandy triangle. And it's a right triangle to be exact. All right, so how tall is that right triangle? 1, 2, 3, 4, 5, 6, 7, 8. 8 units tall. And how long is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 units long. Okay, so my slope is we rose 8, we ran 16, and it's a negative slope. That reduces to -1/2. Now remember, -1/2 is the same thing as saying -1/2 and 1/2. No matter where the negative is, they're all the same. All right, so from point 4, -6, I'm going to graph my slope. I'm going to go, and we want it parallel. Parallel lines have the same slope. So you need to make sure you're talking about parallel and not perpendicular. Have same slope. Okay, so from this point, I'm going to go up 1 over 2, negative. Up 1 over 2. 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 And I'm just getting them all. Down 1 over 2. Down 1 over 2. Down 1 over 2. All right. So now I'm going to check and see which one of those coordinates are on this line. 2, -5. 2, -5. Yes, so I would check that. -2, -4. 1, 2, 3. No, it's -2, -3, so that would be a no. -9, 1. -9, 1. Nope. So that wouldn't be checked. 0, -4. That would work. -6, -1. That would work. And -4, -2. That one works as well. Okay, so just be sure to look and see what is actually on that line. All right, number 12. Which best describes the construction in the diagram shown? The bisector of a line segment. Line L is what's given. Okay, and I'm saying that because it has an L there. And we're not bisecting that line because if we were, we would be cutting line L in half. So that one's not right. Okay? A line segment congruent to a given line segment. We're not given a line segment, we're given lines. So that's not going to work. Okay? Perpendicular to a given line at a point on the line, or we have on a point not on the line. So the point that we're given, is it on the line that's given, or is it off the line that's given? Remember, our given line is L. Point P is not on L. Okay, this is what's given. This line. Point P is off the line, so it's going to be from a point not on the line. So it should be D. All right, number 13. Let me turn the page. What is the inverse? All right, well, let's refresh our memory. our conditional statement is what's given to us. And it's always in P then Q form. Converse, wear your shoes backwards so you can remember. On the wrong feet, that's going to be Q then P. Inverse, not P then not Q. And contrapositive, longest word, and I'll show you right now, C-O-N-T-R-A-P-O-S-I-T-I-V-E, longest word, do everything, not Q, then not P. So we want the inverse, so we're just going to do not P, then not Q. If a measure of an angle is 90, so we want not P. So we want if the measure of an angle is not 90. So we can automatically get rid of C and D. If the measure of an angle is not 90, then it's not a right angle. Then it is not a right angle. There we go. There's our two knots. So A is our answer. Good job. All right. Quadrilateral TUVW is shown. If TUVW is reflected across the y equals x axis, y equals x line, remember y equals x is going to look exactly like this right here. That's what y equals x looks like. It goes through the origin. Okay, what are the coordinates of V prime? That just means where's our V going to be relocated? V is 3, 8, negative 8. So what we're going to do, since y equals x, we're just going to switch their places. And it's going to be negative 8, comma, 3. Here's V, negative 8, 3. It's going to be right here, V prime, because we're reflecting it across there. If we fold these in half, that's where it's going to become. If you look right here, it goes up 1, 2, 3 from 8. So 1, 2, 3. Because these two parts in quadrant 3 are not used. All right, so your ordered pair would be negative 8, comma 3. So D. Any questions? No. All right, next. Number 15. Lines R and S are cut by a transversal. What value of x proves that these two lines are parallel? What are these two angles called? Alternate exterior angles. Alternate exterior angles are when the lines are parallel, alternate exterior angles, look, they're both obtuse, they are congruent. So 3x plus 14 equals 143. So subtract 14. 3x equals 129. Divide both sides by 3, and x is going to be 43. And that's what it wants us to do, just x. All right? Number 16, given, oh, this is a good question. P is 5, 7, and T is negative 3, 3. What is the slope? Oh, the slope. What's the slope formula? M equals what? And yes, somebody just said y equals mx plus b. No. M equals y2 minus y1 over x2 minus x1. Or group 1 minus group 2, either way. Now plug them in. And y2, 3 minus 7 over negative 3 minus 5. What's 3 minus 7? Negative 4. What's negative 3 minus 5? Negative 8. Two negatives give you a positive. 4 over 8 reduces to 1/2. So your slope is C, 1/2. I'll draw a smiley face. All right, any questions about 16? Number 17 is on the next page. For which polygon are both x equals -1 and x equals -2 lines of symmetry? These graphs are really hard to see, so I'm going to blow this up just a smidge. Oh, that may have been a smidge too much. Well, maybe not. Well, we want x equals -1 and y equals -2. Well, x equals -1, this would be this line right here. That is a line of symmetry there. But y equals -2 is going to be, wow, it's going to be down here. Is that a line of symmetry? No. So let's go down here to C. X equals -2. Is that a line of symmetry? Does that cut that picture in half? We have 2 humps on this side. And we have 1, 2, 3 on this side. So that's not being cut in half. So that one doesn't work. Let's go to D. Okay, and it's y equals -2 and x equals -1. Okay, sorry about this, guys. Y equals -2 and x equals -1. So -2 is going to be right here. Ooh, that's a horrible line. And x equals -1. That would be right here. Is that a line of symmetry? Did I do that right? Let me zoom back out of here. Oh, I did 400. No wonder I couldn't see anything. Okay, let's go best fit. Now let's go 200. That's what I wanted. No wonder I thought I was doing this for the visually impaired. -1 and -2. X equals -1. That's why. Because, yep. X equals -1 would be right here. And y equals -2 would be down 1, 2. Yep, I got them backwards. Okay, so that one is a no. Okay, so don't zoom your screen so you can't see the question. That's a bad idea. X equals -1. And don't assume by process of elimination this one's right, because we could easily make a mistake. I know I make mistakes a lot. And y equals -2. -1, -2. Is this a line of symmetry? Are they both lines of symmetry? Yes, you are correct. C is your answer. Okay, let me get back out of this zoom mode. Whew, that's crazy. All right, the figure represents a ramp with handrails. Segments A, B, and D, E are parallel to GH. Segments B, C, and EF are parallel to HG. Segments AG and BH are parallel, oh goodness, to CJ. If the measure of JCB, so JCB, that's this angle right here, is 115, what is CBA? We want CBA. We want this measure right here. I'm going to highlight it. That's funny. Okay. Well, let's think a little bit. Let's play with this. This line is perpendicular. Okay. We know that because there's the right angle down here. What is going on up top since AB is parallel to GH? Okay, all three of these lines are parallel. What's going up here at point B? What's going on? You have a right angle. Okay, so there's 90 degrees. All right, if this is 115, these two right here, these two lines, they're parallel. And if this is 115, what is this angle right here going to measure? These two angles are what? You notice we have a obtuse angle and acute angle. So they're not equal. They are x plus 115 equals 180. Subtract 115 and x is going to be 65. So this is 65 right here. But we're not done with the problem. We want that whole green angle. So 90 plus 65 is going to give us 155. So your answer is 155. All right. Number 19. Reuben attaches a wire between two poles on a heel as shown. Which is the closest to x, the distance between the two poles? Well, we're going to use trigonometry. Some old horse caught another horse, taking oats away. All right? We're standing here at 20. Our hypotenuse is 80. Adjacent is x because you always stand between h and a. And opposite is on the opposite side. So h and a is what trig function? Cosine. So cosine 20 equals adjacent over hypotenuse, x over 80. And when x is on top, kick the bottom out front. X equals 80 cosine 20. Plug it in your handy dandy calculator. Make sure your calculator's on degree mode. Go down to radian, over to degree and hit enter, and clear. So 80 cosine 20. And your answer is going to be 75.17. So D. All right, any questions about that? Here, I'll draw you a smiley face. Yay! Oh, but hubba, dude. Next, number 20. Triangles ABE All right, triangles ABE and ADE, let me change colors, and CBE are shown on the coordinate grid. And all vertices have coordinates that are integers. Which statement is true? What looks true? Okay, when you guys do this,